instructed Kendall and Luis about 20 minutes for their presentation. I think that is feasible for them. It's a real pleasure to introduce Kendall Cloud and Luis near Valderrama. A little context for their project. They started this in August of last year. They were both in a situation due to advising challenges or course curriculum changes or different things that they were both basically stuck in a class with me that they really didn't need, that they had already had. And so anyways, it just kind of worked out that way, unfortunately. But fortunately, this project stumbled into our laps, and I pitched it to them so that they wouldn't have to give up that credit and find another credit and do a little side project like this. And lo and behold, you know, a year later, and here they are, and they'll share what they've been working on. All right, I think we're good. So Kendall and Luis, thank you for doing this. So the floor is yours.
All right, well, good morning, everyone. Thanks for coming here. So I think Dr. Turner got the introduction done almost completely, but Kendall and I would like to share with you what we've done since last semester and hopefully give you a new perspective on the issue that we've been. Well, so just to give you a little overview of what we're gonna look at today, our project is called Pond Creek. We're gonna give you the background of what started this project and what's the reasons why it's important and what are we looking at with this research. We're going to show you how we approach this problem by showing you the methods that we use to collect data. We're going to show you the results, and we're also going to show you what's the work ahead of us.
So Pond Creek is in an agricultural watershed area, kind of sub-humid climate, lots of rolling hills, and highly erodible soil. We've got clay dominant soils. And then, is anybody familiar with College Station area? Just give you an idea where it's at, kind of in that vicinity. As far as precipitation goes, I guess the easiest way to put it would be you have a lot of long duration storms in a short amount of time. So that's a high level of water going into that water basin, and it's constantly flowing. So it's, I guess, even more eroding that soil at a faster pace.
Okay, so well, like she said, it's in the College Station area. As you can see here, this is like the map of the watershed, and this is what it would look like if we look at the whole state. Is within the Pale, Milam, and Falls County here in Texas, and this is where you would see it on the map. And it's a tributary to the Brazos River, so you can see this is the Brazos River, and this is like sort of where it breaks off and it makes the watershed that we're looking at. And so the land use was important to look at because we used it to make some other calculations that we will show you later. But this is just to give you an idea of the historical land use. It's been mainly used for agricultural purposes. You know, corn, wheat, oats were some of the most predominant crops. We looked at the USDA Cropscape in order to get this data, and also the USDA Quick Stats. And so we got this, and the reason why it's important to show this is because it's predominantly agriculture. When all of these solar panel proposals come in, they look at agricultural land. It's really favorable for them because they already have like an access to power grids, and they also have like the terrain already flattened out for them. So the reason why this Pond Creek area is so important is because there's a lot of proposals for solar panels given all of these conditions that we see here.
On top of crop production, you also have a good amount of cattle organizations running. So you have your cattle influencing that soil makeup also.
Racing.
So solar panel interest, one, people like to think that it's a good, clean, green energy source. So, you know, they want to minimize that carbon footprint. There's, it's a little bit more sustainable energy, and there are financial incentives. It's kind of interesting to see some people, I guess, along the East Coast, really. There's really no point blank, I guess, influence on solar panel. They're either interested in it or they're not interested in it, or they just don't care. Some of the planned projects that are being constructed or are already underway are kind of in that same area. We've got one in Otto, Texas, Eddy, Texas, and Marlin, Texas. Otto, Texas is a little bit closer to the Waco area. Marlin is actually just outside of where we were, and same with Eddy, Texas. So then you have to look at your ecological impact. One, you're losing a lot of ground cover because the solar panels are so large. So when it does rain, one, it's going into one specified area that's controlled by that slope of the solar panel. And then if you can see where these solar panels are already installed, kind of see the dead areas, that's never going to come back. If you think about all the installation of windmills in Centenaria, Rockport, if you ever go over there, the thing about windmills is you can still farm around them. With solar panels, once they're in, they're pretty permanent. You lose that piece of, or that strip of land, and there's really no going back from that.
Okay, so the methods that we used to study this case, we used a program called HMS, which is from the Navy Corps of Engineers. Is to simulate the watershed and the conditions and to give us some information of what would happen if there was a rainfall event with the conditions as they are right now, and what would happen if we put solar panels into the equation. And also Kendall did some stakeholder analysis by doing interviews with the landowners in the area. And we also actually went there on the field and we did a watershed assessment to see what the channel conditions were like in real life, besides just the simulation. So for the HMS, you can see this is like a screenshot of what we did there. Like I said, it's from the US Army Corps of Engineers, and it's a program that lets you like map out the catchments of these watershed and lets you basically specify how the sub-basins are, where they are. It can let you use reaches and connect like the whole stream. And yeah, so there's a lot of like settings and inputs that we put into this, but basically we put information such as what the impervious cover would be, what the slope is, sort of how would the different land uses and the presence of solar panels make the conditions different. So we put all of that information in, and then we test it with different rain events and see what the outcomes are. So yeah, this is sort of like a little summary of what we put into the HMS program.
So then with the stakeholder analysis, we were able to get some land access from some owners in the area who will be 100% affected by the solar panel installation. So we used a semi-structured interview protocol and some open coding. Really all that means for y'all is we were able to take the interviews and kind of section it up into environmental effects, economic effects, policy, and some watershed resource effects.
And well, for the watershed assessment, we use NRCS and EPA measurements. So basically we went there and we did a bunch of measurements. We'll show you in a bit what the measurements were. And basically some qualitative, so basically that you see and you can rate the conditions as you see them visually, and also some quantitative ones such as the measurements, the bandwidth, and other sort of measures. So this is a picture of the channel where we were at. And you can see one of the measures, the bankful, the number of pools, the repools. So this has all of like the different elements that you will see on the channel. And we had to take different measurements for all that. Riparian cover basically is what the vegetative coverage is over the soil, and whether it is bare or actually with a cover. So we took measure of that too. And yeah, all of these measurements.
So the stakeholder analysis, like I explained, we have some stakeholders, we've got some effects on land conservation or what they are trying to do to implement what they can for when the solar panels are installed. They're a little bit ahead of the game. If any got some economic effects, some water resources, and political and policy. So with land conservation, they really try to do brush control, and it's imperative in that area to plant those native grasses. They do last a little bit longer. Temperature, once those solar panels go in, your temperature is going to rise a lot during or from the solar panel installation, which is also going to drive your property value down 30%. So if these farmers, ranchers ever did want to move, they're automatically losing 30% of their property value when they sell. As far as water resources, you've got basically an ideal place for a large solar project to go in, has direct access to power lines, pipelines, really just in the middle of nowhere where those things are. But once you add those, you have to have a battery plant, you have increased phosphates, nitrates, and that will be hard on aquatic life. With the policy, there should be a lot of, I guess, pre-motions before these solar panel projects are put in. That hasn't been happening. And one of the biggest statements was, they're not against solar projects. There's a time and place for it, and America's farm and ranch land is not one of them. Then in 2014, this specific owner, when he bought the land, it was extremely overgrazed. So he reduced his cattle numbers and doesn't allow them down by the creek during this winter. So it allows for really healthy growth during the spring. One of the perks that a lot of these solar companies and counties, I guess, promote is that when these solar farms come in, they're going to create tons of jobs for these towns and cities. But in reality, they actually only create one job. You have one maintenance man overseeing, I guess, each project in that area. Everything else is contracted out to who knows where, whatever company they can find. With water resources, you've got 2 to 3 inches of rain in a short period of time. So once that rain is hitting that panel, that's an accelerated motion for the rain to go to the soil or get to the creek, which also causes your erosion probability to go higher. And there's virtually been no research or work done on all the unintended consequences that these large installation solar panel projects will lead to.
So we're going to look at the results now. So, well, just so you can see some of the pictures, this one was upstream from the watershed, and basically this one was downstream. Some of the measures and the average results that we had. The average width was 4.9 meters. The entrenchment rate was 6.67, bank cover 61.9. Soil site stability. Soil stability is basically we take the soil and we measure how resistant it is, like how well water filtrates in it. So basically, if the soil holds still on the test that we did, it means it has a high stability. If it breaks apart instantly, that means it has no stability. So it was 2.8, which is relatively low. Turbidity, bank height ratio. These are just some of the outcomes that we got from the upstream, and these ones are from the downstream. And so from the HEC, HMS, these are a bunch of numbers, but the key takeaways from this, from the outflow, is that basically, well, as you can see, these are the different treatments. So this is 2 inches of rain in 6 hours, 2 inches of rain in 24 hours, 10 inches in 6 hours, 10 inches in 24 hours. So you can see we put different rains and we test them with 3 conditions. One, which is the base, which is as it is now, right now. And then the 401 only, which means that we put solar panels, but only in one subcatchment. So you remember the map that I showed you earlier. So we only put the solar panels like in one of those little areas. And then the smoothed one is basically we put the same number of solar panels, but like evenly spread. So those are like the 3 test runs. And you can see the change from the base. Basically, especially on the smooth one, we see a change of almost 6% from the total outflow, especially if we look at the heavy rain that, the 24-hour one. And this is very significant because the solar panels would only be around like 3% of the whole area. And even with that 3%, it has like a disproportionately large effect. So it's almost 6% of increased outflow, and it's only 3% of the area. So you could even imagine what if it was 6%, would it be like maybe 12% more outflow? And this is just to give you an idea that there are reasons for us to think that the erosion is like super accelerated if we put solar panels in a place like this in farmland. And for the sediment as well, we also did other settings in the HMS to sort of tell us what would the sediment displacement be. And yeah, this is also our results. And like I said before, the main numbers to look at is what was the difference in the cumulative sediment, the tons of sediment displaced. And yeah, you can tell the biggest difference was the smooth one if we put the solar panels all around the watershed.
As far as future work, right now we are with, I guess, Turner. Well, really Turner is trying to create a actual rainfall simulator. So we will be able to, I guess, we'll say make a mock surface that would per se be our solar panel. And we can actually see it in real life in time, what different rainfall occurrences would affect the soil the most. And then we'll look at the quantifiable changes and at a field level. Then we will do mapping and visualization of land use changes. With that, we are trying to approach more of a 3D look at what the land would look like. So that's a summer project as well. And we're going to look at economic feasibility without tax incentives. One of the big things when these solar panels go in, they require approval from your county commissioner, your county judge, and your school board. It's called the 313 amendment. All of those people have to be on the same page. That's been an interesting thing that we found, is that so far all of them have been on the same page, which is very rare. So we want to see if any of that changes within time or over time, or once this Palm Creek solar farm does go in, if there are any policy changes in the area.
And well, just some of the outcomes that we've had so far, or that we hope to get later, is to present, sort of like get outreach, present these results to other people, and sort of raise awareness of, you know, this aspect about solar panels that hasn't really been looked at all, like anywhere. And just publication of a paper, and just, yeah, basically update our poster with the new information that we found on the field. And yeah, this is sort of like the things to work at in the future.
With acknowledgements, we were provided land access from Matt Goodson and Robert Fleming, and information from interviewers with Lynn Fleming, Rusty Burns, and Wally Burns.
And yeah, also we obviously use resources from USDA, and so like the HMS and the Cropscape, all of that, and we use their resources. And yeah, Kendall is with the CREST program, so that's why we credit them here. Any questions?
Okay, first give him a hand.